Okay, so the next question we're going to deal is right along with me. What is valency? Okay, we're going to understand this valency. Write two examples. So what we're going to do in this class is just write along with me. We'll first write the definition and everything without explaining so much, and after we have written down the definitions and examples, then we're going to explain it using the specific example. Okay, so just write the definition. Whether you understand properly or not, that's fine now. Just write it down. In simple terms, the combining capacity of an atom, of an element, combining capacity of an atom, that means any atom of any element of an element is called its valency. So that is the simple definition of valency. But with this type of definition, it's hard to understand. So let us go deeper, and the more proper definition which will make us understand better will be the next one. So I'm going to say, in other words, another way of defining, better way. In other words, just write it down first. Okay, in other words, the number of valence electrons in an atom, the number of valence. We know what is valence electrons. We have learned this in the previous class. Electrons in the outermost shell. So the number of valence electrons, an atom of an element, an atom of any element, or an element, an atom of an element can give, can gain, G-A-I-N, very key word, or lose, or share. These are the three keywords. The number of electrons that any atom can gain means get, lose means give away, share means not exactly take or give also, but sharing with some other atom. So in other words, the number of valence electrons that any atom can gain or lose or share, share with one or more other atoms, with one, it can be one, or more, that means two or three, more, one or more other atoms, other atoms, in order to attain, this is important. Why do they do this? Gain, lose, share. The purpose is in order to attain, means to achieve, to attain the electronic configuration, electronic configuration means simply the manner in which the electrons are arranged in any atom. Like first shell 2 electrons, second maximum 8. That arrangement given by Bohr-Buer rule is called electronic configuration. Of the nearest noble element or noble gases. Nearest noble gas, because all the noble elements are gas, so you can just write gas also. Noble gas is called its valency. So that is the definition. We may not clearly understand now, it's fine. Just write it down. It's called its valency. I'm going to take examples. When we take the examples, write it down and follow me. Then I'm going to explain. I didn't take too much time explaining the written words, but I'm going to explain with the examples. So give two examples. So let's take first example. The best way to understand is by example. Example 1. Let's say this also, you write it down first. Electronic configuration. Electronic configuration of sodium. Sodium, we know the symbol is Na. electronic configuration of sodium, which is Na, is given by, according to Borbie rule. We already know, we did this in the first class, right, for 3D 2, and it has got 8 electrons in the second shell, and then in the third shell it has got 1, because atomic number is 11. 2 plus 8 plus 1, 11. So the electrons are distributed in the first shell 2, second shell 8, third shell it has only 1 valence electron. This electron in the last shell here, 1 electron, is called the valence electron. So that is the electronic configuration, means arrangement of electrons in a sodium atom. Okay, it loses, why does it lose? I'm going to explain. It loses 1 valence. It will lose this 1 valence electron. Why does it lose? Do you remember? The number of atoms, valence electrons, gain or lose or share. In this case of sodium, it's losing. Okay, to form sodium ion. To form sodium ion. Okay, sodium ion is, we know, Na plus. So how do we get this Na plus? Okay, Na plus, sodium ion, Na plus, and since it loses this electron, when sodium atom loses the 1 valence electron, it become first shell 2 and 8 second shell. No more 1 because it's lost. That means 1 electron lesser. So plus sign is coming out. So let me explain this little bit here. No need to write. Okay. Here you see sodium atom has got, we know, we drew this structure in the last class. It has got 11 protons and 12 neutrons, and it has got 11 electrons. 1, 2 plus 8 in the second shell. No need to draw. Okay, 3, 4, 6, 7, 8 plus 2, 10, and the last shell valence electron 1. So you see, number of protons, how much? 11. Proton has positive charge, so 11 positive charge. Number of electron also 11. And every electron has 1 negative charge. So when you combine, plus 11 minus 11 is 0. So the charge of atom is neutral, 0 charge. But here 1 electron is lost. This lost means this is now out. Then it has got, proton is not touched, so it's still there, positive charge, 11 protons. But 1 electron lost here means only 10 electrons are there. So only 10 negative charge. So 11 minus 10 will become 1. And here 1 negative charge less, so 10. So 1 positive charge dominantly is coming out. Therefore 1 electron lost, so 1 positive charge. Had it lost 2 valence electron, then it would have been 2 plus, right? So I hope you're getting why the plus sign is coming out, because 1 electron is lost. 1 less electron means 1 less negative charge, so 1 extra positive charge is showing up there. So that is called the ion. So why does sodium atom form the sodium ion? So that it will form sodium ion, okay, which is valence electron to form sodium ion. Full stop. Okay, why does it form this one? To attain the, we can write here, to attain the electronic configuration. To attain the electronic configuration of the nearest noble gas configuration, neon, I think, which has 2 and 8. In the first class we did, right? Neon has got 2 and 8. So here, this is perfect noble gas. So sodium atom wants to become like neon. How does it do? If it loses 1 electron, it will become 281, will change to 28, which is the exact electron configuration of neon. So sodium is losing 1 electron in order to become like neon configuration. So sodium ion configuration 28 is the same as neon atom 28. Okay, that's why they lose electron here. Full stop. Okay, then chlorine atom. Now at the same time, chlorine, CHLORINE, chlorine atom gain. As I said, valency, we know that valence electron is lost, gain or loss, lose or share. Sodium is losing, but at the same time chlorine is gaining. Chlorine atom, okay, chlorine atom which is configuration. Okay, let me write down chlorine atom Cl. We know 17 is the atomic number, so 2 plus 8, 10 plus 7, 17 electrons are there. So we'll gain 1 electron. Chlorine atom configuration is like this. Gains this electron. Which electron? Gains this 1 electron. This electron lost by sodium here. This lost 1 electron here is taken up. The gain means taken up by chlorine. Gain this electron to form chloride ion. Chloride ion. See here. Cl 2, 8. 1 lost here. Gaining here means 2 plus 8 plus 7 plus 1, 8. Why to attain the electronic configuration of the nearest noble gas configuration of argon, which has got 2, 8, 8. Perfect. So chlorine, see here, 288, here also argon. So chlorine becomes like argon, 288 like argon, by taking 1 electron from sodium. So then becomes chloride ion, see here. Chloride ion, so Cl minus. Why minus? Because it has gained an electron, 1 extra electron. So 1 extra negative charge means 1 negative. 1 negative charge lost, so 1 positive charge appear. 1 negative electron gained, so 1 negative. If it gained 2 electrons, it would mean 2 minus. Did you get it? So here, this is what is happening. Now let us draw the figure to understand it. That means here, sodium atom. In the electron structure, we draw only the valence electron. Okay, sodium atom has got 281, means it has only 1 valence electron. That's represented by dot. Okay, then this is the sodium atom. You can write along with me. Na 1 valence electron. So the diagram, this dot represents electron, and the dots are only for valence electron. So we should not draw 2, 8, but only this one. So this is this representation for sodium atom. Sodium atom lose 1 valence electron, so it will lose this. Okay, so here it lost, this means 1 electron coming out plus. So it's no longer attached to this one, so it becomes Na. So since 1 electron, now this is here 2, 8, 1. You can write it down. Sodium atom. It lost 1 electron means this one is lost, so only 2 and 8 here. So 2, 8. That means 1 positive charge will appear. And this is called sodium ion. The same structure as configuration as 2, 8, that of neon. So it happens like that by losing this 1 valence electron. Okay, so this number of valence electron losses here 1. Okay, so since, you can write here at the back, since it is a sodium atom loses 1 valence, okay, 1 valence electron here. Okay, so its valency is 1. The number of electrons lost or gained or shared to form noble gas configuration like neon 2, 8 by any atom is called, the number of electron lost or gained or shared is called, in order to gain the stable structure of any nearest noble gas is called valency. So since it's losing only 1 electron, so its valency is 1. So that is the meaning of valency. Now continue. Now this lost here, this electron lost here. Okay, this electron lost here, this electron, okay, excuse me. Okay, so this electron lost here by sodium is gained by chlorine atom, and we know chlorine atom has got 287 electrons in the first, second, and third shell. So this is chlorine atom. It gain means this will become 1 electron added here means 2, 8, 7 plus 1, 8. So it will become chloride ion. So this is your, you can write it down, chloride ion. Okay, chloride ion. So chloride ion, this one. And chloride ion is the configuration of argon, the noble gas, 288 here also. See, 288. How did it become 8? Because 7 plus 1 electron, 8. So 1 electron gain. So since you can write here at the back, since chlorine atom, Cl, okay, Cl means chlorine atom, gains 1 valence electron here, so its valency is also 1. Number of electrons gained by chlorine, 1. So its valency is 1. So how do they combine? We're going to show in the third step. So let me just take here. So here, this sodium becomes sodium ion. So we just here, sodium atom Na has got 1 valence electron. So this is 2,8,1. This is sodium atom, and chlorine atom is here 2,8,7. So there are 7 valence electron, means that's represented by this. Okay, so here represent this valence electrons by of that of sodium by dot and chlorine by cross. Okay, 1, 2, 3, 4, 5, 6, 7. We are allowed to draw only the dots or the cross for only valence electrons. It has 7, so draw 7 dots. So here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. This one we're drawing. The last valence electron we're drawing as dot for sodium and cross. So what happened is, this two step is saying this 1 valence electron is lost by sodium to chlorine, and chlorine takes up, so they will become like this. And so since 1 valence electron is lost, sodium has lost, means it has become plus, and the configuration has changed to 2,8 because 1 is lost, right? This 1 loss is taken by chlorine, so 1 extra negative charge, electron is negative, so 1 negative charge appear, and here 2,8,7 has become 2,8,8. So how does that happen here? 1, 2, 3, 4, 5, 6, and 7. Chlorine atom has 7 electrons valence only, but this dot electron is given to gained by chlorine. So this dot is actually, it was that of sodium given, so it has taken 1 extra. So therefore 1, 2, 3, 4, 5, 6, 7, 8. Therefore it has negative charge. So because of this, here negative charge and positive charge, because it is lost 1 electron, positive, it gained 1 electron, so negative. A force will be formed between these two. Like this, attraction. So this is called electrostatic force. Electrostatic force. And this force will hold these two ions, sodium ion, chlorine ion, together and form sodium chloride molecule. This is the salt we eat in our curry, okay, nimok, right? So that's how salt is formed, by sodium losing 1 valence electron and chlorine gaining that 1 valence electron from sodium. Then electrostatic force developed between a positive and negative charge ion. So sodium chloride molecule is formed. So this example of sodium chloride molecule formation explains to us the valency is here. 1 electron is lost, see dot there of sodium, and 1 gained by chlorine. So since sodium lose 1 electron to gain the structure of neon 2,8, and chlorine gained that electron to gain the structure of argon 2,8,8 electronic structure. So that is called the valency. So since it gained 1 electron, so chlorine valency is 1, sodium lost 1 electron, so valency is 1. That is the concept of valency. Okay, now let me show you another example of valency. This one's example 2. Here let me just take here methane molecule. Okay, example 2. Example 2. Methane formula, you write down just CH4. So how is this methane molecule formed? As you can see, there is one carbon. So you write here one carbon. Atomic number of carbon is 6. So first shell 2, second shell 4. Because according to Bohr-Bury, first shell has got maximum 2, second shell has got maximum 8. So maximum 2. So 6 total electrons means 2, 4. So 4 valence electrons. So let's just draw 1, 2. Okay, 1, 2, 3, 4. One carbon. So 1, 2. So these are the 4 dots representing these 4 valence electrons. And there are 4 hydrogen atoms here. So each hydrogen atom, atomic number is 1. So here 1 you write. So here let us represent by cross. Now these 4 hydrogen atom will attach to this carbon. How? See here. Carbon 1, 2, 3 and 4. 4 hydrogen atoms. So 1 will come here and then combine with this share. Not loss also, not gain also. This is an example of share. Hydrogen will share one of its electron with carbon, and the next hydrogen will come here and share second one. The third one will come here and share here. The fourth one will come and share here. 1, 2, 3, 4, bringing one electron here. This one bring 1 and share. Sharing means here hydrogen is saying I'll give my valence electron, you also give carbon. So that means it's not loss or gain. That means your belongs to mine, mine belongs to you. So sharing. So common property now. So hydrogen has 2 valence electrons. Now 2. Hydrogen here 2. Hydrogen here also 2. Having the configuration of helium. Helium has got the electronic configuration 2. Noble gas in the first shell. So fulfill the noble gas. And then carbon, you count, share. All these are share. So you just round it off like this. Now around carbon, how many? 1, 2, 3, 4, 5, 6, 7, 8. So this carbon has now become 2, 1, 2, 3, 4 gain. So or 4 shared. So 4 plus 4. 8, and has the configuration of neon now. So how does the carbon achieve the configuration of neon? By taking 1, 1 from the 4 hydrogen to make 8, 2, 8, 4 plus, all the cross are hydrogen, 1, 2, 3, 4, 8. And how does the hydrogen achieve the helium? By taking 1 from carbon to form here helium for each, another one here. So this is example here. Carbon share 1, so valency of carbon, it's 1. Each hydrogen, valency of hydrogen. Each hydrogen also share 1, so valency is 1. So the number of electrons gained or lost, like in the case of chlorine and sodium atom in the previous one, and here, number of valence electrons shared, like in the case between carbon and hydrogen, to form a compound is called valency. So the valency of carbon is 1 because it is sharing. Valency of carbon is not 1 here. It share here all the 4, 1, 2, 3 valence electrons. So here 1 to 1 hydrogen, second one to another hydrogen, third one is sharing 4. So the valency of carbon is therefore 4. But hydrogen, each of them is sharing only 1 here with carbon. So valency is 1. Here also 1 hydrogen, this hydrogen sharing 1. Since carbon is sharing 4 of its valence electrons with each of the 4 hydrogen atoms, so it's sharing 4, so the valency is 4. I hope you got it. Okay, that ends the class for this session. Okay.